So this is the video for section 2.2, day 2. Last class we learned that we can take the derivative of a polynomial, and for each term in the polynomial we can use the simple power rule, which says that to take the derivative we're going to take our coefficient times, oops, I wrote that backwards. It should be x to the n. So our coefficient times our exponent, and then we will multiply on our x raised to 1 less in the degree. So if we're taking the derivative of a, x to the n, we're going to get a times n, x to the n minus 1. So that's the rule we're going to use, and you can use it with polynomials. You can use it anytime you have anything in the form of a number times x to a power, whether that power is a fraction or negative or a positive integer that would make a polynomial. So if we look at a here, the first thing we have to do is, at least in our minds, realize that x is to the 1/3 power, and then we can use our rule to take the derivative. We'll take 4 times that 1/3. We'll take our x and drop the degree down 1 whole. We also talked about how if we are taking the derivative of a constant, we always get 0. So I'm just going to say plus 0, even though I don't really have to be that exact about it, because I'm just going to assume that you will drop off any constants when you're taking the derivative. Don't forget to write your answer with a positive exponent. So even though 1/3 minus 1 is negative 2/3, we're going to write our final answer as 4/3x to the 2/3. We'll do the same thing with b. For b, we are going to have 4 times negative 3. And then we're going to subtract 1 from negative 3, and so our new exponent will be negative 4. Negative 2 times negative 2. We'll subtract 1 from our exponent, and it's negative 3. One thing I want you to practice now is factoring out. So it's been a while, but that was on your first quiz. I want you to factor out 4. They both have a common factor of 4, the 12 and the 4. And the lowest degree on x being negative 4, you'll be left with negative 3 plus x. And your final answer, you got the 4 times the negative 3 plus x all over x to the 4th. So if you're a little rusty on the factoring out, make sure that you work through that and distribute if you need to prove it to yourself. But this is the time where this is going to come back into play, and we're going to have to be able to factor out to simplify. That's what I mean up here, factor out any common factors. For c, our coefficient is 7/8. You can find it right here. And the power that t is being raised to in the function is the 2/3. And it's in the denominator, so we're going to call it negative 2/3. And that's how we're going to change this from being a fraction to being something that I can use this rule on. So now my derivative is 7/8 times negative 2/3, t to the negative 2/3 minus 1. Or negative 7/12. And then I've got t to the negative 5/3, so I'll put positive 5/3 in the denominator. And for d, it's a little trick. It looks like a fraction, but it's not, because when you put a negative exponent in the denominator, it's the same as putting a positive exponent in the numerator. So if you think about the rewrite, your derivative is simply 9x squared. Same kind of thing for e. A negative exponent in the denominator means nothing is in the denominator. In this case, because there's nothing else there but this thing with the negative exponent. So it really is the same as 2x cubed squared. But I still know how to take the derivative of that. I need a number times x to a power. I don't want the power out here. So I'm going to square the 2 and square the x cubed. And now I have something that looks like I can take its derivative. And I will get 24 x to the 5th. So one thing you want to be careful of is make sure you let me know when you've gone from rewriting your function to actually taking the derivative. And then on f, pi is a number. So in this case, pi is your coefficient. And the power that you have on x to start, that's why we practiced over and over again. How do you simplify the square root of x over x? It's x to the -1/2. So I need to know that to rewrite it so that it looks like the form that I need to take the derivative. And now it does. So I will take pi times -1/2. Call that negative pi over 2. I will take the exponent of -1/2 and subtract 1 from it to get -3/2. And then I will take that -3/2 exponent and put it in the denominator as a positive. Moving to the back, you cannot take the derivative of a function raised to a power. We haven't learned how to do that yet. If you happen to know something called the chain rule from having calculus before, then you would know how to do it, but we haven't learned it yet. So I'm going to FOIL out x plus 3 so that I can then look at each piece and take its derivative. X squared, derivative is 2x. 6x, derivative is 6. 9, derivative is 0. For h, we practiced a bit how to rewrite something like this. The easiest way to imagine it is to break it up into 3 separate pieces. And then I'm still rewriting, I haven't taken the derivative yet, but I can divide out an x from here, divide out an x from here, divide out the x's there, and I can take my derivative now. 9x squared minus 4. If we look at I, the test there is just to make sure you know that the cube root is the 1/3 power, the 4th root is the 1/4 power. Your derivative is 1/3 x to the -2/3 minus 1/4 x to the -3/4. Now factoring out in this case is a little bit tricky because you don't have a common denominator for your fractions or your exponents. So what that's going to look like is if we get a common denominator and call that 4/12 x to the -8/12 and call this 3/12, sorry, x to the -9/12, then we can more easily see that I want to pull out a 12th from these denominators. And we want to pull out the lower of the 2 degrees, which is -9/12, so that's smaller. And then I would be left with my 4 from here. And I'll be left with an x to the 1/12 minus a 3 from here. And then I can write it as 4x to the 1/2, or you could go back to the square root if you like, 12x to the 9/12. And last but not least, we're going to do something like we did in h. We're going to do a rewrite that has a 1/2 power as the denominator for both of the terms in the numerator, which can lead us to rewrite this as 2x to the 3/2 because we're going to take 2 minus a half, and 3x to the 5/2 because we're going to take 3 minus a half. And now that's still the function, but now I can take the derivative. 3/2 times 2, subtract 1 from the degree. 5/2 times 3, Subtract 1 from 5 halves, and I get 3 halves. No negative exponents. I don't really need to factor out. I can just leave it like that. If you wanted to factor out a 3 and an x to the 1/2, you definitely could, but it's not going to make it any more simplified. So that is my quick run through of going a little deeper on the derivatives in this section. There's an extra credit sheet that I told you about that you can do to turn in when we come back. And you'll find that on Canvas if you don't have it already. I'm trying to see if I have a copy of it. It just says extra credit 2-2, but you can find that on Canvas if you don't already have a copy. It's 5 problems, 2 points each. You can get help however you need. You also have a web assign that will be due on Friday as well.